Hello, in this video we are going to look at evaluation of a type 2 integral. First of all, we need to set up the limits of integration to integrate over the following triangle. So the triangle has vertices 0, 2, so that would be right here. Let me just mark it. Okay, so 0, 2 is 1. Then we're also going to have 1, 1, so that's another point right there. And then 3, 2. Okay, so there is our triangle. Okay, now to go ahead and set up the limits, the first thing you have to ask yourself, does this region look like it can be expressed as a type 1 region? So for type 1 region means that you have one curve on the top and another curve on the bottom, which does happen here, but the problem is that the bottom curve consists of a piecewise defined function, right? Because over here you have one line with one slope and y-intercept, and then you also have over here another line with a different slope and intercept. So if you did this by using a type 1 strategy, you will have to break it apart into, like, you would have to consider you would have to like break it here and go from 0 to 1 and evaluate that integral, and also go from 1 to 3, evaluate that integral. So this is more difficult. But as a type 2 integral, this is where you're expressing it in terms of the, it's going to be dx out inside and then dy outside. So here, the y limits would be the extreme values of y, not x. Okay, so let's just say that's going to be from here to here. That's how y changes. So this would be 1 to 2. And then what you do is you have on the bottom here the left curve, and then on the top is the right curve. So if you're going from left to right, the left curve would be the red line, right? And then the right curve is going to be the orange, right? So this is going to be like, this is left and then this is right. So left to right. Okay, so you're going to need to write down an equation of a line that goes through, first let's do the red line, right? So the red, it goes through the points 0, 2, and 1, 1. Okay, so let's see if we can find the slope. So remember, the slope formula is y2 minus y1 divided by x2 minus x1. So here is x1, y1, here is x2, y2. Okay, so this is going to be 1 minus 2 divided by 1 minus 0. So looks like that's going to be negative 1. Okay, and then the y-intercept formula is y1 minus slope multiplied by x1. So y1 is 2, subtract slope, which is negative 1, multiplied by 0, and that will just be 2. Now you can also see, in this particular case, you can see that the y-intercept is at 2. So you can see that the red line intersects the y-axis at 2. Okay, so actually, let's go ahead and see if we can come up with this equation. So now we have y equals mx plus b. So that would be negative x plus 2. Now, here is the problem. Because the outside variable is y, unless this region is a rectangle, which I hope you can see that it's not a rectangle, these limits, the inside limits, will not just be numbers. Maybe one of them can, but both of them cannot. Because if both of them are, then that's a rectangle, which again, this is not a rectangle. So you have to know that one of these limits, or possibly both, have to have a variable in them. Like which one? Well, always the outside variable. So if the outside variable is y, these limits should have y in them. Okay. So you can't just take negative x plus 2 and put it as your bottom limit over here. Like this is not good because you want the outside variable to be here. And so what that means is that you have to re-express this equation in terms of x equals something of y rather than y equals something of x. So let's see if we can do that. Basically, we have to solve for x. So we're going to subtract 2 from both sides. So I'm just going to get y minus 2 equals, here we have negative x. And then I'm going to multiply both sides by a negative, which means that we'll get something like this. So remember to distribute the negative to both terms. So we're going to get x equals negative y plus 2. So that would go as your bottom limit, which is left curve. So here, type 2 region, it's left to right, left to right. Okay, so then what remains is also come up with the equation of the the orange line, which is the right. Okay, so that line goes through 1, 1, and it goes through 3, 2, right? So just looking again at the picture, this is 1, 1 right here, and then 3, 2 over here. That's the orange line. Okay, so let's see if we can come up with the slope. So again, this is x1, y1, this is x2, y2. So slope is y2 minus y1 divided by x2 minus x1, which means 2 minus 1 divided by 3 minus 1. Okay, so looks like that's going to be 1/2. And then the y-intercept is y1 minus mx1. So y1 here is 1 minus m is the slope we just found 1/2 times x1, which is 1. So that's going to be 1/2. So this line is going to have equation y equals 1/2 x plus 1/2. But we still have to also re-express this as x equals something of y. Okay, so let's subtract 1/2 from both sides. So we're going to get y subtract 1/2 equals 1/2 x. So this is going to cancel here. And then the last step to solve for x is multiply both sides by 2, right? So that this 1/2 cancels out over here. And then we distribute the 2 to both terms, and that gives us 2y minus 1 equals x. So that goes in here, 2y minus 1. Okay, so let's see if we can put that in here. So 1 to 2, negative y plus 2, 2y minus 1. Okay, so what remains is actually computing this integral. So we have to compute this integral of 6y. All right, so let's do that here. So we've got 1 to 2, then negative y plus 2, 2y minus 1, and then we are integrating 6y dx dy. So first concentrate on the inside integral. Here you are integrating with respect to x first, right? And when you integrate with respect to x, always remember that the other variable is considered a number. So how do we integrate a number? So we know from the univariate calculus that if you have just a number and you integrating it with respect to x, that just means kx, right? Because derivative of kx is k. 5x derivative is 5. So when you integrate k, this will be kx. Here, the role of k is the 6y because it does not have an x, so it's like a number, which means that it's just going to be 6yx. Okay? And then we're going to substitute, and here's important because we are integrating with respect to x. When you substitute in your limits, it's going to be x equals negative y plus 2, and then x equals 2y minus 1. And again, the outside integral still stays dy. We have not gotten to that point yet. Now, when you integrate, always remember that the top limit comes first. You substitute that for x, right? And you are specifying that it's x equals 2y minus 1. So this is going to become 6y multiplied by parentheses 2y minus 1. Then we subtract 6y, and now we substitute the bottom limit, right? The bottom limit is the second one. And so that's going to be negative y plus 2. We're substituting that for x. Okay, and again, we still have the dy outside. We have not done that yet. Remember that before you start integrating the outside integral, you must simplify the expression that you are integrating. So do not move on until the expression is completely simplified and all the like terms are combined. There are no parentheses left. There should be no parentheses at the end. Okay, so let's just distribute. This is going to become 12y squared minus 6y. Then it's going to be plus 6y squared, and then minus 12y. Okay, well, you can put parentheses around the whole thing. Just inside, there shouldn't be any parentheses. Okay, now, do we have like terms? So remember, like terms are the terms with the same power. the same power of the unknown. So here I've got these two terms that I can combine, and I also have these two terms that I can also combine. All right, so this is going to become 18y squared minus 18y. Now I cannot combine anything because y squared and y are not the same. This is like apples and oranges. You cannot combine. Now you are finally ready to integrate the inside. So how do we do that? So remember, we have a power rule for integrals. The power rule for integrals says that you add 1 to the power. So unlike derivative where you subtract 1, here you add 1. So you're going to get y to the power 3, and then you divide by the same thing. So you can do over 3. However, I don't like that. So I usually, instead of dividing by 3, I multiply by 1/3. So I don't like the stacked kind of thing that where it's not clear, we're dividing, multiplying, whatever. So I just like to do, instead of dividing by 3, multiplying by the reciprocal 1/3. Okay, and then minus 18. Now y is the same as y to the power 1. Okay, so that's going to become y to the power 2 when we add 1. And then again, we divide by 2, which means the same thing as multiplying by 1/2. Okay, and again, now we can draw the vertical slash, put the bottom limit and the top limit over here. Okay, so let's see if we can simplify a little bit. 18 divided by 3 is 6. And then 18 divided by 2 is 9. And now we're ready to substitute the limits. So first, remember, we start with the top. And now you don't have to say y equals 1, y equals 2, because you only have one variable left. So now that's going to become 6 times 2 cubed minus 9 times 2 squared. So that's a 4. Subtract. Now substitute 1 for y. So that's just going to be 6. Now here you got to be very careful because you're subtracting the whole thing. So I would put that in parentheses, and that's going to be minus 9, right? And then I would distribute the minus. So don't forget that. So this is 6 times 8, which is 48, minus 36. And then minus, well, here actually I can just compute 6 minus 9 is negative 3. So I'm subtracting 3, which means I add 3. Okay, so looks like if I subtract 48 minus 36, that's 12 plus 3. So looks like I got 15. Now, there are a lot of places where this could go wrong. And let's see. Well, it did not.